Hello everyone. In this lecture I shall discuss the complex logarithmic function. Okay. Now if you recall the logarithmic function in real number system, right? We have the natural logarithm log x to base c, or we write it ln x. It is defined for all x positive only, okay? In the positive real axis only. However, here log z defined is defined for all z except at z is equal to 0. Except at one point z is equal to 0, it is defined everywhere and it is analytic. Now to find details of your log z, right, you know z is r e to the power I theta, or that is z mod e to the power I theta in exponential polar form. Now if I want to find what is ln z, right, what is ln z, then your ln z will be ln r e to the power I theta, right? So this is equal to ln r plus ln e to the power I theta. Ln and e are reverse of each other, so here this will be equal to ln r plus I theta. Now this theta is argument, so this theta is argument. So the theta may be principal argument, of z, or theta may be your general argument of z, right? It is general argument of z. If theta is your principal argument, it leads to principal value of the log, right? It leads to principal value of the log, right? And if it is general argument, then it leads to your general value of log. It is small l and it is your capital L. However, these two connects as your argument of z, right? Your argument of z is your argument of z plus 2n pi, right, as already we have seen earlier. So in that way we can also connect it. Since you know this, so we can also connect it. How to connect it? Your ln z, small ln z, it is your general value, is your principal value, right? Principal value plus and minus 2n pi I, right? Plus and minus 2n pi I. So this I is because we have a I here, okay? We have a I here. So this is I is multiplied even if there is no I here. Now this is called the general value of log, okay? General value of log, right? And this is your principal value, right? Principal value of log. Principal value of log, right? And one more information you should note. You should note that your argument of z has to lie in between, right? Minus pi smaller than capital argument of z is smaller than equal to pi. So this is the restriction, okay? This is your minus pi. So now this restriction is there for your principal argument, right? So principal argument has to be restricted. Accordingly, the properties of the logarithm for principal value will be restricted under this argument, okay? So for the details discussion of the logarithmic function, we must know the argument of z. First we have to, so we should work with this, means first we have to find the principal argument and accordingly the principal value of log, and it will followed by your general. For this point of view, let me to remind you what is the principal argument, how to find the principal argument, okay? You have to find the principal argument. Principal argument you have to find. So as you know, this principal argument has to lie in between this is the range. So you may be in the first quadrant, You may be in the second quadrant, you may in the third quadrant, you may in the fourth quadrant, right? Let my alpha is tan inverse y by x mod. So my recalling my principal argument, my minus pi less than argz here less than equal to plus pi. Let I take my alpha is suppose tan inverse y by x mod. Ignoring the sign, let my alpha is tan inverse. Suppose I take alpha as tan inverse y by x mod, right? Suppose my alpha is, ignoring the sign, tan inverse y by x mod, right? Y by x mod. So now z is equal to x plus iy. So if my z is here, then what is the principal argument? Here argz is equal to tan. Let z is here x plus iy. Then here argz will be tan inverse simply alpha. Alpha means it is tan inverse of y by x mod. If it is in the second quadrant, then it will be here. If it is here, right, then the smallest angle created here is this angle, is smallest angle is created. It is here pi minus, so argz here will be pi minus alpha. And if it is here, then here argz here will be alpha minus pi. And if it is here, it is better in this opposite direction. If here it is theta here, and here it is in opposite direction, and here it is argz is equal to minus of alpha. So minus of tan inverse y by x mod. Okay. So in that way, we have to see where the complex number lie. One more thing, if the complex number is here, right, if it is here in the positive real axis, then the argument here is 0 here. And if it is here, then the argument in the means I, 2i, right, then here the argument is pi by 2. Now if it is here, means minus I, minus 2i, whatever it may be, then this argument here is minus of pi by 2. If you have here negative real axis, then means here minus 1, minus 10, whatever it may be, then here the argument is here pi, right? Argument is here pi. Okay, so this is what we have discussed. So before the details of the discussion, let me to introduce myself. Myself, Professor Kumar Paikray, currently working as a professor of mathematics at Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. So without much delay, let me to discuss the details of this logarithm, principal logarithm and general logarithm. Now just to repeat your argument of z, let z is equal to x plus iy. It may be plus minus x plus minus y, yes or no? So z may be, and let my alpha is tan inverse of y by x mod, right? Tan inverse of this. Now if z is in the first quadrant, if it is in plus plus, then here argument of z is here simply, it is in first quadrant, right? Then here argument of z will be simply tan inverse of y by x mod, right? And if it is in the second quadrant, right, then here argument of z will be pi minus tan inverse of y by x mod. Now if it is in the third quadrant, it is minus, then the principal argument of z will be tan inverse y by x mod minus here pi. If it is in fourth quadrant, it is plus minus, then your argument of z will be minus of tan inverse y by x mod, right? And what is your alpha? Alpha here we have written. So your argument of z, principal argument of z has to lie here. Your principal argument of z, minus pi cannot include and pi we can include. Okay, So that means your argument of z lie in this interval, open interval minus pi, closed interval plus pi. Okay. Now if it is in the real axis, right, if it is in the positive real axis, argument of x, right, x positive here, in positive real axis it is here 0. Argument of here minus x, positive, negative real axis is here pi, and argument of 0, you mark argument of 0 is undefined. Okay, argument of 0 is undefined, right, that's why. So consequently log 0 is undefined, okay, consequently you can have log 0 is undefined. So therefore you have log 0 is undefined. Okay, so from this viewpoint, as I have told you, so here the argument is here tan inverse y by x mod. Consequently, as I have told you, here the argument of z here is here tan inverse of y by x mod, or I write just alpha. I write the argument of z here is alpha, here alpha, and here it is pi minus alpha, and here it is alpha minus pi, and here it is minus of alpha. Okay, and here if it is here or 10, 20, 50, whatever it may be, and here this argument of z is 0 here. Okay, and here it is suppose it is 10i, suppose it is 50i, whatever it may be, the argument here is pi by 2. It is here suppose minus 5, minus 10, minus 100, whatever you say, the argument here is pi. And here suppose it is my minus I, minus 20i, whatever it may be you say, the argument here is minus pi by 2. These are the principal argument. Now we are ready to discuss the logarithm. So for details you should refer my lecture 2. Okay, lecture 2. You should refer for the details. For details you should refer. Okay, now we are ready to find the logarithm. What is my principal value of logarithm? Principal value of logarithm, right? So here capital ln z, as I have told you, it is ln z mod plus I, this is argz, right? And this is equal to, you can write ln x square plus y square root over plus I argz, you may write it tan inverse of y by x, and with the scheme of this arg, but it should be here arg. Okay, so now that is equal to, you can write half ln root over half ln x square plus y square, half ln x square plus y square plus I argz in that way. So this is my principal value of logarithm, right? This is my principal value of logarithm. Now to what is the general value of the logarithm? General value of logarithm. So for the general value of logarithm, I write it is small l, right? So here for principal it is capital L, for small it is general value, it is small l log z. It will be your principal value of log plus 2n pi, your principal value of log, right, plus and minus 2n pi I. Here n is a natural number. And why it is so? Now it is because here log z, if I write it, it is ln z mod plus I argz. So what is your argz? So this is equal to ln z mod plus I, it is argz, okay, plus 2n pi, right? Now up to this, it is my principal value, ln z, and this together with this plus 2n pi I. Here n is an integer. N is integer. Okay, n is integer, right? N is natural number. Sorry, n is a natural number. Now also I may write it ln z plus and minus 2n pi I, right? In that case, here n is a integer. If I write here n is an integer, if I write it plus and minus, then n is a natural number. Okay, n is a natural number. So in that way, so in order to find the logarithm general value, first we have to find the principal value, then we have to find the general value, right? First we have to find the principal value, then we have to find the general value. You see, in both the cases, this L is small, right? Whatever it may be general or it may be principal, this L must be small. So let us solve some examples. So one more information I will say, like because of this argument, right, this log is a multi-valued function. So I can say log z is a multi-valued function, but right, a multi-valued function, but it is non-periodic. Multi-valued function, it is not periodic, right? It is not periodic. So don't be confused. So it is not periodic log z. Okay, complex log, it is a multi-valued function and it is non-periodic. But if I recall here, but what is here ln x real, right? It is single valued. And non-periodic too, And what happens to your e to the power z? It is single valued, but many one, but it is periodic, but periodic, right? But periodic. Now suppose you are asked to find the principal value as well as the general value of all these things. So coming to your solution 1, okay, let z is equal to your 1 plus I. So it is in first quadrant. What is your ARGZ? First we have to find. It is tan inverse of 1 is pi by 4. Okay, it is pi by 4. So what is your principal value? Ln z is small ln z mod plus I ARGZ. So we will write it. So what is your z mod? Z mod is your root 2. So this is equal to ln root 2 plus I pi by 4. Okay. So capital ln z, the principal value is this, right? And what happens to your general value? Your ln, so this is your capital ln 1 plus I is this, right? Capital ln 1 plus I is here this. Capital ln 1 plus I, you get it, right? Now what happens to your small ln 1 plus I? So this is equal to capital ln 1 plus I plus and minus 2n pi I, right? So this is equal to your ln root 2 plus I pi by 4 plus and minus 2n pi I, when your n is an integer, natural number, because we are taking both plus and minus. If we take only plus, then it is I. Then what happens to your 2i? This is my 2i, this is my iv. For 2i, z is equal to minus 1 plus I. Okay, solution 2i. Let z is equal to minus 1 plus I. It is in the second quadrant. So what is your argument of z? Your argument of z is pi minus tan inverse of y by x mod. It is y is 1, so it is 1. So this is pi minus pi by 4 is 3 pi by 4. And what is your z mod? Is minus 1 square plus 1 square root over is your root 2. So what is your principal value of minus 1 plus I? It will be ln, this L is small, right? ln minus 1 plus I mod plus I argz. So this is equal to ln root 2 plus I 3 pi by 4. Okay, so this is the principal value. Now what is my general value? So my general value ln minus 1 plus I, it will be what? I have to write it ln minus 1 plus I plus minus 2n pi I. Okay, so this is equal to here ln root 2, or I can write half ln 2 plus I 3 pi by 4 plus and minus 2n pi I. Or if I write plus only, then I should write here n is an integer. Okay, in that way. So this is your general value, right? Next, if you are asked 3, z is equal to minus 1, 3, solution 3. Here z is equal to, right, z is equal to here minus 1, 3i. This is solution 2i, this is solution 3i. Let z is equal to minus 1. So z is equal to minus 1 is here negative real axis. So this argument here is pi, right? So what is here argz? Argz is equal to here pi. And what is here z mod? Minus 1 mod is equal to 1. So here ln minus 1 is ln, mark this L, is ln minus 1 mod plus I argz. Okay, so this is equal to ln 1 plus I pi, right? Ln 1 is 0, 0 plus I pi, so this is equal to I pi. So this is the, okay. So now what is your general value? So ln minus 1 is I capital, the small ln. So this is the general value here, small ln minus 1, right, is equal to your principal minus 1 plus and minus 2n pi I. So this is equal to, I can write, or if I write plus, then it will be my, so this will be my I pi plus 2n pi I, n is an integer. Okay, so I can write it 2n plus 1 pi I, n in an integer, right? Next coming to 4, what is the value of z is equal to 5? Coming to 4, solution IV, z is equal to 5. So here what is argument of z? Argument of z is here 0, right? And z mod is here 5. So ln 5 is ln 5 mod plus I argz, arg 5, right, arg 5. So what you can do? So this is equal to, you can write ln 5 plus I 0. So this is simply ln 5. But what is your general value? So ln 5 is ln 5 plus 2n pi I. Okay, n in here I. So this is equal to ln 5 plus 2n pi I. Or if I write plus and minus, no issue also. Plus and minus, I can also make it plus and minus 2n pi I if n is a natural number here, right? So this is the value of your general value, right? Basic facts, some basic facts. If I say what is your ln 1, it is your 0. However, if I ask you what is your ln 1, right, ln 1 will be your 0 plus minus 2 pi I plus minus 4 pi I because of the periodicity. Okay, if I write ln minus 1 and it is your plus minus, it is your pi I simply, and but your ln minus 1 if you write, it will be plus minus pi I plus minus 3 pi I plus minus 5 pi I, in that way, right? So if I ask you ln z1 z2, so this is equal to ln z1 plus ln z2, right? If I ask you ln z1 by z2, so this will be ln z1 minus ln z2. and you mark it. This is your small, means for general, but this ln z to the power n, it cannot be n ln z, right? It cannot be because of the multiplicity of n, right? Because z times n, it converted to the power function here, right? So in general it will not hold. And moreover, for your principal value, right, you can write capital Ln z1 z2, it will be equal to capital Ln z1 plus capital Ln z2 if and only if your argument of z1 plus argument of z2, okay, will lie in that interval as desired, right? So it is not true in general. That means capital Z1 Z2 is not equal to capital Ln Z1 plus capital Ln Z2 in general, right? This restriction is needed here. This restriction is needed. Similarly for the extension of fourth. So likewise here for principal value, and this has to be within this restriction. Now log 1 by z is minus ln z if z is positive, okay? So in general, ln z to the power n is not equal to n ln z, even if it holds in real. So it will hold if n is positive, then it will hold. Next 9, d by dz of ln z is 1 by z. Z is not equal to 0. So ln z is differentiable everywhere except at origin. So likewise, so thus ln z is analytic everywhere except at origin. Okay, if you think of its proof, if we think of proof 9, what is your ln z? It is ln z mod plus I argz. This is real part and this is imaginary part. This is real part and this is your imaginary part. In that way we can split. So this is equal to, you can write it, half ln x square plus y square plus I tan inverse of y by x. So this is my u and this is my v. I find my ux. What is my ux? My ux is equal to x by x square plus y square, okay? X by x square plus y square. And what is my vx? Vx is my minus y by x square plus y square. So what is my f dash z? F dash z is equal to, you know, ux plus I vx during the proof of the necessary part of Cauchy-Riemann equation we have discussed. So that is equal to here x by x square plus y square minus I y by x square plus y square. So this is equal to x minus I y by x square plus y square, right? So this is equal to, this is z conjugate divided by z conjugate. So because z conjugate is z mod square is x square plus y square, okay? So this is equal to here, this is equal to here 1 by z, provided this denominator is not equal to 0, okay? Provided z is not equal to 0, right? So this is differentiable everywhere except at origin, right? So here ln z derivative, right, derivative is 1 by z except at z is equal to 0. Coming to your property number 10, you know e to the power z is e to the power z plus minus 2n pi I, because 2n pi I is the period of exponential function, right? So but here, you know, here what is the argument of e to the power z? Argument of e to the power z is here y plus 2n pi plus minus 2n pi n in n, okay? This is the argument of z. So from this viewpoint we can say ln e to the power z, ln e to the power z, ln e to the power z is usually e to the power z, sorry, is here z, okay, is here z. But from this viewpoint, I can write here ln e to the power z, keeping this aspect in mind, okay, I can write it, it is here z plus n minus 2n pi I, right, we can write it. However, ln z is not periodic, okay. So in view of this we may write it. So ln z is not periodic. So these are the basic properties of the logarithm function. Now let us solve some important problems. Now you see, now this is because I can write it ln e to the power z. E to the power z is periodic. Ln e to the power z plus minus 2n pi I. So now this is z plus minus 2n pi I. Okay. Coming to here 11, a to the power z is e to the power z ln a for all z in C. Okay, for all z in C. So now coming to the solution of 1 a. So you are asked to find ln e. What is the formula? You know. So this is ln e mod, and e is in the positive real axis plus here I. So just we should write it ln z mod is equal to ln z mod plus I argz because I am talking about the general value. So this is equal to, it is because of the general value. So this is ln z mod plus I argz plus minus 2n pi. In that way I can solve simultaneously, right? So I can write it ln e. So ln e is equal to ln e mod plus I. So it is argument is 0 here plus n minus 2n pi. Okay, so ln e is here 1 here. So this is 1 plus, right, plus minus 2n pi I. Now coming to the solution B. Ln e to the power I. So you can write it, general value we need. So this is my ln e to the power I plus minus 2n pi I, because e to the power z is e to the power z plus minus 2n pi I. So what is the value? So this is 1 plus n minus 2n pi I. Then coming to the third one, ln minus e to the power minus I. Solution C, ln minus e to the power minus I. So this is ln minus 1 into ln e to the power minus I. So ln minus 1, you can write it ln minus 1 mod plus I argz I pi, right, I pi, I argz here, I argument of minus 1, and into ln e to the power minus I. Okay, so this is equal to, I can write ln 1 plus I pi, and this in line with this, what you can write it. So this is, sorry, ln a b, it is ln a plus ln b, right? So this is plus, it is ln e to the power minus I plus minus 2n pi I. So this is equal to ln 1 is 0 plus I pi. So it is minus I plus n minus 2n pi I. So this is equal to here pi minus 1 plus n minus 2n pi I. So this is your answer. Okay, coming to question number 2. So you are asked to solve for z. Okay, the general value is given here. So solution I, here ln z is e to the power e minus pi I. So this implies, what is your z? It is e to the power e minus pi I, right? So I can write it e to the power e minus pi I plus 2n pi I can write, n in, suppose I say. So this is equal to, I can write, separating real and imaginary part, e to the power e into e to the power 2n minus 1 pi I. So I may leave it here n in I, or I may split it. So this is e to the power e. It is cos 2n minus 1 pi plus I sin 2n minus 1 pi. In that way also I can stop it here, n in integer. Now coming to 2i, solution 2i, it is asked ln z is minus pi I by 2. So what is your z? Z is e to the power minus pi I by 2, and I can write it. It is because of the period, e to the power minus pi I by 2 plus 2n pi I plus n minus 2n pi n in n, natural number. So I may stop it here, or I may continue in this line. Okay. So solution I, you are asked to find the general value of this. Let z is equal to I to the power I. So that means here ln z, since general value we write small ln, so this is I ln I. I apply the formula here. So this is equal to I ln I mod plus I argument of z plus 2n pi, right, since we are making general. So this is equal to I ln I mod is ln 1 is here 0 plus I, since it is I, the argument here is here pi by 2, right. So here it is pi by 2 plus 2n pi. Okay, so this is here 0, so we can write it. So this is I into this I square minus 1, so this is minus of pi by 2 plus, or I can write minus also, plus minus 2n pi, n is a natural number. So I can close it here, right. Then coming to 1 plus I to the power 1 minus I, solution 2i, let z is equal to 1 minus I to the power 1 plus I. So in the same line you can continue. So here general value we need, so this is 1 plus I ln 1 minus I, we apply the formula here. So this is equal to, the formula is ln z mod plus I argz, okay, plus minus 2n pi. So we can apply this formula here. So what is your z mod? Z mod is your root 2, it is in the 1 minus I in the fourth quadrant. So here argument z is minus pi by 4. So we can write it here. So it is 1 plus I whole into ln root 2 plus I argz is minus pi by 4 plus minus 2n pi, right. Now I just multiply it and simplify it of the form of u plus iv, right. I should continue it. So now you are asked to prove the following. So let your w is equal to sin inverse z. So that means your sin z, your z is equal to sin w. Sin w you can write it e to the power iw minus e to the power minus iw by 2i. Okay, so you can simplify it. So that means my cross multiplication 2iz is e to the power iw minus 1 by e to the power iw. So that means 2iz e to the power iw is equal to e to the power iw square minus 1. So that means e to the power iw square minus of 2iz e to the power iw minus 1 equal to 0. So this is a quadratic equation. So this implies your e to the power iw is equal to minus b. It is 2iz plus minus root over of b square minus 4ac by, it is minus 4z square plus 4 by 2. Okay, so this is equal to iz minus b plus minus root over b square minus 4ac. Okay, so this is plus and minus, it is 1 minus z square root over. Okay, so what is your iw here? Your iw is equal to ln of iz. If I omit the negative sign, it is plus root over of 1 minus z square. So that means here w is equal to I is taken to this side. So minus ln iz plus root over of 1 minus z square. Okay. So it is minus I ln this. So this is proved. Coming to 2i. So for 2, let tan inverse z is w. So w is tan z sin z by cos z. So I write it e to the power iz plus e to the power minus iz by 2i, and this is cos z is 2 by here e to the power iz, this is minus, plus e to the power iz. Okay, if I simplify it now, so this will give you, if I go on simplifying, I will get z e to the power 2iw plus z is minus I e to the power 2iw plus I. Okay, if I simplify it, it is z plus I e to the power 2iw is equal to I minus z. So that means e to the power 2iw is I minus z by I plus z. Okay, so that means 2iw is equal to ln I minus z by I plus z. So what is my w? W is equal to 1 by 2i ln I minus z by I plus z. So now I can write it minus I by 2 ln I minus z by I plus z. So now bringing minus sign to inside here. So it is I by 2 ln I plus z by I minus z. So it is proved. Coming to proof 3. So coming to the last question. So let me put this. So what is your z? Z is cos hyperabolic w. So this is e to the power w plus e to the power minus w. Sorry, it is e to the power minus w by 2. E to the power minus w divided by 2. So that means here 2z is equal to e to the power w plus 1 by e to the power w. So 2z e to the power w is e to the power w square plus 1. So that means e to the power w square minus 2z e to the power w plus 1 is equal to 0. This is a quadratic equation. Ax square plus bx plus c, this is a quadratic equation. So what is here? E to the power iw is minus b plus and minus root over of b square minus 4ac minus 4 by 2a, right? So this will be z plus and minus it is z square minus 1 root over, right? So what is your iw? Iw is equal to ln z. So I omit the negative sign. So z plus root over of z square minus 1, right? So here it is e to the power w. There is no I, na? So w is equal to this. So what is your w now? So that means my w is equal to here cos hyperabolic inverse z is equal to ln z plus root over of z square minus 1. So it is proved. Okay. So it is proved. So w here, w means here w means here tan inverse z, right? W means here tan inverse z, and here w means here what? Sin inverse z, right? So this is here sin inverse z. Okay. So with this we should conclude this lecture. The lecture is getting lengthy. We should close it here. So this is all about your logarithmic function. So we should close this lecture here. So now the key fact of this thing is that we have to see the properties and how it different from the real number system, right? The counter real functions here, there are so many similar properties, still there are the differences, so we have to mark the differences. Okay, so if you feel this lecture is useful and interesting, please like and subscribe to this channel, which will boost my motivation to upload subsequent lectures for your benefits. So thank you all. Have a nice day.